Let's talk baseball. My favorite thing about baseball is how different players come together to work as a team to accomplish a goal. We have something very similar to that in our bodies. We have a system of different proteins that come together as a team to work as a biological clock to keep time in our cells. I'm sorry. Wow. Yeah, okay, thank you. So keeping time is fundamental for nearly all life on Earth. This is a scoreboard. This scoreboard is a perfect representation of how chronobiologists of today can actually view and observe these biological clock systems. They can see when runs are scored, the final score, and some additional information like hits and errors that we can relate to conformational changes of proteins and protein-protein binding partners. The problem with this is that it lacks details. We can see what the entire team is doing, but the individual players, we aren't sure how they're working together to accomplish these results. And that's where my PhD project comes in. No longer are we tuning into ESPN to get the latest recap of a sports game like this here. Instead, I'm buying tickets to the game and watching it in real time from inside the stadium. On the top, what we're showing is one player as if a camera has been locked onto him for the entire duration of the game, showing him fielding, running the bases, and even smiling after he scores a run. For my biological clock system, the players are like our proteins that are keeping time, and the camera is just like a chemical tag that I'm physically attaching to these proteins so that we can observe them. On the bottom is data that I've collected in lab showing a chemically tagged protein as its binding activity over 2 weeks for showing this beautiful 24-hour rhythm. But not only can I watch one protein, I can actually place labels on multiple different proteins and to where I'm watching the entire team in real time as the game progresses. This is the latest model of our biological clock system, showing all of the players. I like to think of this as the face of the clock, and my new methodology is the key that it's allowing us to open it up and peer at the gears turning on the inside. Who here wouldn't like to sleep better? That's what I thought. In addition to sleep patterns, these biological clocks have recently been linked to debilitating diseases like Alzheimer's and insomnia. My work is pushing to discover how these clocks lose their timing and what we can do to correct it and even prevent it. Because after all, timing is everything. Thank you.